ax squared. Find the value of a if f of x is continuous at x equals 3. Just confirmation. Alright, nice and easy. Now the second part of the question says, it says if y is equal to x over the square root of 1 plus x, determine an expression for dy by dx. So it says y is equal to x over the square root of 1 plus x. Y is equal to x over the square root of 1 plus x. So if y is equal to x over the square root of 1 plus x, find dy by dx. I'm going to use implicit differentiation. Alright, I can't bother to work with, oh, well, let's not do that then. I just couldn't bother work with the square root. Let's just differentiate it normally. So dy by dx is equal to, you start with the bottom, which is 1 plus x square rooted times the differential of the top. The differential of x is 1, so minus the top being x times the differential of the bottom. The differential of the bottom is carry down the power half, then you subtract 1 from the power, which is 1 plus x to the minus half subtract 1 from the power, yeah, divided by the square of the denominator, which is 1 plus x. Better to use implicit. I wouldn't have to be working with no negative powers. So yep, square root of 1 plus x, carry down the half, subtract 1 from half is minus half, times the derivative inside the bracket of 1. So this is fine. So simplifying this, we're going to get that this is equal to the square root of 1 plus x minus, now this part can be written as minus x over 2 times the square root of 1 plus x. All I'm doing is simplifying this, and all of this is divided by 1 plus x. The question said to simplify your answer fully so you're not finished. You can then write that this is going to be multiply up 2 times the root of 1 plus x, and you're going to get 2 times the root of 1 plus x times the root of 1 plus x is just 1 plus x. So you get 2 times 1 plus x. You get 2 times 1 plus x minus x over 2 times the root of 1 plus x divided by 1 plus x. Which is equal to this divided by this. Now 2 plus 2x minus x, that's going to be 2 plus 2x minus x. That is this divided by this. It's simplified. 2 plus 2x minus x is just 2 plus x. So all of this just works out to be 2 plus x divided by this. So it's going to work out to be 2 plus x divided by 2 times the square root of 1 plus x times 1 plus x. Nice and easy. That's the answer. 2 times the square root of 1 plus x times 1 plus x in the denominator. Alright, that's the answer. Now, would implicit have been easier? Or, this is for persons that would have wanted to do it implicitly. You could have done it implicitly by going squaring both sides. You'd have gotten y squared is equal to, that would have been x squared over x squared over, when you square this, the square would cancel, so you just get 1 plus x. Alright, and then I'm going to rewrite this as x squared times 1 plus x to the negative 1. I'm going to use implicit. Using implicit, differentiating both sides now with respect to x, you get 2y times dy by dx, 2y dy by dx. That would be equal to, keep the first, that means times, keep the first, times the derivative of the second. The derivative of the second would be carry down the power minus 1, subtract 1 from the power to get 1 plus x to the minus 2, plus keep the second times the derivative of the first, plus keep the second times the derivative of the first, which is 2x. This is telling me that 2y dy by dx, if I had to continue around here, I'm getting 2y dy by dx. This is if you wanted to do it implicitly. 2y dy by dx would work out to be equal to, this part is going to simplify to be minus x squared over 1 plus x all squared. This would be minus x squared over 1 plus x all squared then I have plus 2x over 1 plus x plus 2x over 1 plus x. And so I could then divide through by 2y. Dividing through by 2y, that would then tell me that dy by dx is equal to, dividing through by 2y, I would get that it is equal to minus x squared over 1 plus x all squared times y plus 2x over 1 plus x times y. And then you could resubstitute what y is. Remember what was y? Y was x over the square root of 1 plus x. So you could resubstitute then and get that. It's a good thing we didn't do it implicitly. It's actually a longer method. So we get that dy by dx will be minus x squared over, this would be 1 plus x squared, 1 plus x all squared times the square root times y now, and remember y in this case is x over the square root of 1 plus x plus 2x times 1 plus x times y, and y would be x times the square root of 1 plus x. This is way longer, implicit, so don't do implicit there. 1 plus x. And then to simplify this now, and you'd want to say, oh gosh, I have to simplify this. Yes, to simplify this now, you would have to go that this would become minus x squared over 1 plus x squared times x. Remember, 1 plus x squared is 1 plus 2x plus x squared. And then you multiply that by x. So it would be 1 plus x squared times x, 1 plus x squared, 1 plus x all squared. And this would be times x. And it would be all of this is divided by the square root of 1 plus x. Now when you have this now, let me just do it in one step. Think of it as a divided by b over c. It works out to be a times c. So I'm just going to do it in one step. All of this, I'm just going to do it in one step. A divided by b over c is a times c. So it works out to be minus x squared times the square root of 1 plus x over x times 1 plus x squared. And then as you realize, for this side, the x cancels the square. And then this part will give you plus, it's going to be 2x times the square root of 1 plus x over, this is x times 1 plus x and this x cancels this x, and so the final answer that you get is pretty much the same as the other one. The final answer is the exact same thing. We just need to simplify it some more. So in this case, it gives us that dy by dx is minus, we could make the LCM 1, and so it is minus x. If you want to make the LCM 1, it's really minus x times 1 plus x times the square root of 1 plus x plus 2 times the square root of 1 plus x over 1 plus x. All square. So this is dy by dx. All right, this is an alternate way to do it. You could actually factor out 1 plus x. The square root of 1 plus x, you could factor that out and simplify in the bracket. You're going to eventually get back the same thing. All right? So either way you do it is fine. Either way. Now part C. Part C tells us that dy by dx, it says x is equal to cos theta. So let's do that. X is equal to cosine theta. X is equal to cosine of theta. And it tells us that y is equal to the sine of theta. X is equal to cos theta and y is equal to the sine of theta. And so first thing we need to find is dx d theta. So dx d theta when you differentiate costs, let me write that better. That's not gonna look too pretty. So when you differentiate with respect to theta, so dx d theta is going to be equal to, when you differentiate costs, you get minus sine theta. Alright, when you differentiate costs, you get minus sine. And then when you differentiate, you find dy by dx, or dy by d theta. When you differentiate sine, you get cos. All right, nice and easy. So what does that mean? That means that dy by dx, is going to be equal to dy by d theta, times d theta, times d theta dx. And so it's going to work out to be dy by d theta is cos theta times d theta dx, which is really divided by the minus sine theta. But then cos over minus sine is minus cot. And so dy dx is minus cot theta. All right, nice and easy. That's what we have, minus cot theta. All right, nice and easy. And this takes care of question 5, soft. All right, finally, question number 6. Question number 6 says the gradient of a curve passes through the point -1, -4, and is given by, you tell us that dy by dx is equal to 3x squared minus 4x plus 1. And it says, find the equation of the curve. To find dy by dx, right, since you already have dy by dx, then the equation of the curve y is going to be equal to the integral of dy by dx. So y is equal to the integral of 3x squared minus 4x plus 1. That's dy by dx. 3x squared minus 4x plus 1 dx. That is y. So now you integrate that, and what you're going to get is 3x cubed. You get 3x cubed over 3 minus, add 1 to the power, you get 4x squared over 2 plus 1, that's just x. Alright, plus some constant c. Alright, and that's the equation of the curve. If you want to go ahead and simplify it, you're going to see that y is actually just x cubed minus 2x squared minus 2x squared plus x plus c. Nice and easy. Now you need the point -1, -4. So at -1, -4, at -1, -4, y is -4. So it's going to be -4 is equal to -1 cubed, which is -1, minus 2 times -1 squared plus -1 plus c. That will allow us to find the constant c. All right, so solving for c, we're going to see that -4 is equal to, put it in the -1, we get -1 minus 2 times -1 squared plus -1. That is -4. So -4 is equal to -4 plus c. And so the constant is 0. So if the constant is 0, the curve passes through the origin. And so hence the curve is going to be, this is part I, the curve is just going to be y is equal to x cubed minus 2x squared plus x. Nice and easy. So now the second part of the question says, find the coordinates of the stationary points and determine their nature. So to find the coordinates of the stationary points, well, that's no issue. So we go ahead now and to find the coordinates of the stationary points, we go ahead and solve dy by dx equals 0. So we solve dy by dx equal to 0. We solve dy by dx equal to 0. By solving dy by dx equal to 0, we are solving 3x squared minus 4x plus 1 equal to 0. And by solving this equal to 0, we factorize it. By factorizing it, what we're going to get is signs are the same, and both of them is negative. So this is minus, this has to be x, and 3x. And so the stationary points are going to occur when x is equal to 1, or when x is equal to 1 over 3, 1 upon 3. So now that these are the two stationary points, what do we do? Now x is 1, we need to find y. When x is 1, we plug in 1 here, we have 1 cubed minus 2 times 1 squared plus 1. So when x is 1, we get y is 0. Then we'll put in 1 over 3. We're going to have 1 over 3 cubed minus 2 times 1 over 3 squared plus 1 over 3. And that's 4 over 27. So this is giving us y is 4 over 27. So those are the two stationary points. So let me just put it as a point. You have 1, 0. Then you have 4 over 1 over 3, 4 over 27. That's another stationary point. 4 over 27. Now you need to find out what is dy by dx. Now it says determine their nature. So since we need to determine their nature, we need to find the second derivative to do that. So the second derivative d2y by dx squared, that's going to be equal to, you differentiate dy by dx to get 6x minus 4. All right, 6x minus 4. Now at the point 1, 0, the second derivative, don't, just for space, second derivative is often written as y prime prime, meaning you differentiate y twice. At 1, 0, y prime prime is equal to, you plug in 1, you get 6 times 1 is 6 minus 4 is 2, which is greater than 0. And so therefore 1, 0 is a minimum point. So 1, 0 is a minimum point. And then now you need to find y prime prime over here at 1, 3. At the point 1, 3, you have y prime prime is going to be equal to, when you plug in 1 over 3, you get 6 times 1 over 3, 2 minus 4 is negative 2, which is less than 0. And so 1, 3, 4 over 27 is a maximum point. So this right here is a maximum point. That's a maximum point. Nice and easy. So we have the minimum point and we have the maximum point. Now that we have the minimum point and the maximum point, it says hint, sketch the graph. So to sketch the graph now, we create our, I like to